this is 3-phase AC current injection test bench. The capacity is 2500 ampere 3-phase here. Here you can see the input voltage is 415 volt 3-phase 4-wire 50 Hz AC. Capacity is 15,000 VA per phase. Just because this is 2500 ampere at 0 to 6 volts. That is why this is 15,000 VA per phase. And the duty is intermittent, 5 minutes on, 10 minutes off. And this is air natural cooled unit. The manufacturer of this test bench is S.B.ELECTROTECH, Kolkata, India. So here you can see this is the mains input MCB for protection and also for powering on the testing panel. Here this is the cam switch for RY, YB and RB phase voltage indication. This is the digital voltmeter for input side voltage indication, and this is the switch for this voltmeter. Here this is the input side frequency meter. This is for input side frequency measurement. Here you can see these three are fuses for protection. These are mains on indication lamps. Here this is a digital time interval meter for time in which time the object which we are testing with this test bench is tripping. We are using this for measuring the tripping time. Here NO and NC mode, and here also common NC and NO terminals are provided. By these two crocodile clips we can measure the time. And here this is digital panel 3 nong digital panel ammeters. This is for R phase, this is for Y phase, and this is for B phase only. And here this is a zero start interlock in and out facility is provided. If at the time of testing zero start interlock is needed, then we have to put this into this position, otherwise we have to put this in out position. And this is the start indication lamp. These are start and stop push button switches. And here these three are dimmers. We will regulate the current by rotating this in this clockwise direction, and we can decrease the current by rotating this in anti-clockwise direction each phase. And here this is the current for R phase, Y phase and B phase. Regulators are here. And here you can see for output section, these are the bus bars here. This is the R2, Y2 and B2 here, and this is R1, Y1 and B1. This is basically neutral portion which is shorted by this bus bar here. This is the neutral is shorted, and these three are R, Y and B phases output. So now for the operation, at first we will start the test bench by pressing this MCB on. And after MCB on, now we are selecting the zero start out function here, and you can put it in zero start in. Then the current will be only, we can increase the current when the DMR is in 0 position. If we turn this in position, and after that we only can on the test bench if the DMRs are 0. But if the DMRs are in a higher range, then we cannot switch it on. So at first we have to turn the dimmers in 0 position, and after that only we can turn this on. So now we will increase the currents in each phases. You can see the current is increasing. We can set any current in any phase here. The maximum current we can reach is 2500 ampere, and over the current if we reach over than 2500 ampere current, the set will automatically tripped off. Here we have reached the 2500 amps current in every phases, and we also have to maintain the current balancing at the time of increasing the current in each phases. We must balance the current, otherwise it will act like three-phase transformer, and if we don't balance it, then we cannot set 2500 up to 2500 ampere at one time. So after completion of testing here, otherwise after the test complete or the product which we are testing, if that trips, so now you can see this is in NC position. So if the product trips, that means the NC will be automatically turned to NO, and the set will be tripped off, and the current will be decreased to 0. And here this is the time in which time the product trips. So if the tripping occurred, then you can see here in these three displays the current will be turned to 0. So this is the process of testing here. So after completion of testing, we must turn these current regulator knobs to 0, and after that we will turn this MCB off.